Hi, in this video, we want to look at the concept of Cramer's rule, looking at how to use Cramer's rule to solve a system of linear equation. So let's say we're given the linear equation. How can we solve using Cramer's rule? So let's look at our first question. So we may be given an equation 2x plus y equal to 5 and 3x minus 2y equal to 4. And we're asked to use Cramer's rule to find the value of x and y. Of course, we're used to this type of simultaneous linear equation, but only in this case. If you had encountered a question like this, you would have gone through the method of either elimination, substitution, or graphical approach. But what if we want to use the Cramer's rule to solve a question like this? So what do we do? So first thing we want to do is to write this equation in form of matrices. So remember, to write the column picture first. So that's 2, 3. So neglect the variables for now. The what's it called? The coefficient of y here is 1, and this is negative 2. And then we'll write the unknowns in this method, x and y. So we want to write it like this. So this will be equal to 5 over, sorry about that, not over, so 5 and 4. All right, so why are we writing it like this? Why are we writing it like this? We're writing it like this because, what's it called? We've not changed this equation at all. Remember when we dealt with multiplication of matrices, we said these two matrices, before two matrices can be multiplied together, then the number of column of the first matrix must be equal to the number of row of the second matrix. And then the order of multiplication has to be this row times this column. So if I multiply this row by this, so I'll be having 2 times x, and then 1 times y. So you can see this is what I'll have at this top here. So I've not changed the course of this question. I've only rewritten it in a more suitable form for us to apply Cramer's rule. And the next thing to do after writing your equation like this is to find the determinant of this matrix, this one on the left hand side. So just find the determinant of this matrix. The determinant of this matrix would be, so we have 2 over 3. So let's say 2, 3. So determinant is 1, negative 2. Okay, so determinant here will be 2 times negative 2. So that's negative 4. 3 times 1 is 3. So minus 3. So negative 4 minus 3. So that's negative 7. So negative 7. So that's my determinant. All right, so after finding the determinant, you can just write determinant of, so let's say we're giving this to be a, so is equal to negative 7. I'm writing it outside there just because of space, because I'm still going to come back and use this value. So, but for now, let's try and clear up this. Okay. Now, after finding the determinant of the matrix, you now want to replace the column picture. What do I mean by column? Each of these column, this is the x column, this is the y column. So I want to replace this column by this other matrix at the other side and find the determinant. I don't know whether that makes sense. This x column here, or the column picture of x, I want to replace it with 5 and 4 in such a way that I have a new matrix that will look like this. So 5, 4, 1, and negative 2. I've not touched the inside. I've not touched the y place. I only replace the x column with what it is equal to. After doing this, then you want to find the determinants of this also. So this will be the determinant of x. Then you do the same thing for y. That will be the determinant of y. It's quite easy. Okay, so find the determinant here. So what do we have? 5 times minus 2, so that's negative 10. 4 times 1, that's 4. So negative 10 minus 4, so that's negative 14. So then this will be determinant of x is equal to negative 14. So I want to do the same thing for y. So doing the same thing for y, I'll have okay. So doing the same thing for y again. This is the original matrix, so 2, 3. Now the column picture for y, I want to replace it with 5, 4. So replace this with 5 and 4, and also find the determinant. So finding the determinant here, what do I have? I'll simply, so 2 times 4, that's 8. 3 times 5, that's 15. So 8 minus 15, and 8 minus 15 gives us negative 7. So delta y is equal to negative 7. So after getting all these values, then you can now what's it called? Find the value of x and find the value of y. So how do we find the value of x? So x will simply be equal to delta x over the or determinant of x rather over the determinant of the original matrix. y will be equal to determinant of y over the determinant of the original matrix. Okay, so computing this, so what is my x, or the determinant of x? So that's minus 14. And what's the determinant of the general matrix? So that's negative 7. So negative cancel out negative, 7 here 1, 7 here 2. So x is equal to 2. So what is y? Y is negative 7 over negative 7, and then this is positive 1. So y, x is 2, y is 1 in this equation. So let's try and put it inside of this equation and see whether we can verify our answer. So when x is 2, so 2 in the bracket of 2, y is 1 plus 1. So will this be equal to 5? 2 times 2, that's 4 plus 1. So that's equal to 5. So let's put that in the second equation. So 3 in the bracket of 2 minus 2 in the bracket of 1. Would this be equal to 4? 3 times 2, that's 6. Rather, so 6, 2 times 1, that's 2. So 6 minus 2, that's 4. So you can see the solution to this set of linear equation is 2 and 1, what we've gotten using Cramer's rule. Okay, so let's see how we apply Cramer's rule to a 3 by 3 matrices. Let's say we're given x1 minus 4x2 minus 2x3 equal to 21, 2x1 plus x2 plus 2x3 equal to 3, 3x1 plus 2x2 minus x3 equal to negative 2. Okay, so for 3 by 3, we're given this, and then we have to find x1, x2, and x3. So we want to do the same thing we did when we're doing the 2 by 2 problem, so using Cramer's rule. So first of all, we want to write the matrix here. So quickly writing the matrix. So 1, 2, 3. Okay, negative 4, 1, 2. Okay, negative 2, 2, negative 1. And then multiply this with x1, x2, and x3. Okay, and this will be equal to 21, 3, and negative 2. Now you have to be careful while computing to ensure that your signs are perfect, otherwise it changes the course of the solution. So remember, we find the determinant of the matrix first. So determinant of matrix A, determinant of matrix X, x1. Okay, so let's just use the appropriate variable. So x1, x2, x3. So this is equal to and this. Okay, so let's look for determinant of A first. So remember, this has plus, negative, positive. So let's start. So take 1, of course, cover this. I'm left with 1 times negative 1, so that's negative 1. You need to be careful about the sign. The sign is quite important. The sign is quite important. So if we strike this, So 1 times negative 1, we say negative 1. Then 2 times 2, so that's 4. So but we're going to subtract it from this, so we're done with this part here. Then moving on to the next one, so I have negative 4. Okay, so open my big bracket also. Then what do I have? I have okay, so after striking this and striking this, so 2 times negative 1, so that's negative 2. Okay, 3 times 2, that's 6, so negative 2, negative 6. Okay, so I think this is okay. Okay. Then lastly, plus negative 2, open our big bracket again. Then strike this, so 2 times 2, that's 4. 3 times 1, that's 3. Okay, so let's try and simplify. So negative 1, negative 4, that's negative 5 times 1, negative 5. Negative 2, negative 6, that's negative 8. And negative 8 times 4, so that's 32. But will the 32 be positive or negative? I think it should be negative. Negative, because negative, that's negative. Negative, that's positive. Positive, negative, that's negative. Okay, so 4 minus 3, that's positive, that's 1. Times negative 2, so that's negative 2. So what do we have here? So negative 5 minus 2 minus 32. So that's minus 39. So this is equal to negative 39. So you want to write negative 39 out here. So that's the determinant of the original matrix. So just like we did for the 2 by 2 matrix, it's time to start replacing the x1 variable, the x2 variable, and the x3 variable. So you can see we're just repeating the same thing. So we repeat that, and then we'll find the determinant. Okay, so let's just do the matrix here, the replace matrix. So remember, I want to use this to replace the x column now. So here I'll have 21, 3, negative 2. So please be careful about the sign again. Negative 4, 1, 2, negative 2, 2, negative 1. Okay, so again, find the determinant of this matrix. So plus, minus, plus. Okay, so take 21. 21 is outside. Okay, strike this. What am I left with? So I have 1 times negative 1, so that's negative 1. 2 times 2, that's 4. So negative 1, negative 4. So I think I'm done with the first one. Moving on to the second one. Since this is negative, this place is negative here, and this is negative also. So negative, negative, that will give us positive 4. So I hope it is not confusing. I want to write it so that when we're simplifying it will be easier. But if it's confusing for you, you can write this negative here and then write this negative 4 in parentheses. So okay, so this is positive 4, and then you can open your big brackets. Now strike this. I'm left with 3, negative 1, negative 2, and then 2. So 3 times negative 1, so that's negative 3. 2 times negative 2, that's negative 4. But remember, it is negative 3 minus 4, so that becomes negative 3 plus 4. So I hope that makes sense. Then moving on to the next one. So you can see the place sign here is positive, but the sign of the element is negative. So plus times minus is minus. So I can write my minus here and do my big bracket. Okay, so doing this, what do I have? Strike this. So 3 times 2, that's 6. So 6. 2 times minus 2 times 1, that's minus 2. Minus 2 times 1 is minus 2. So 6 minus minus 2, that's 6 plus 2. Okay, so here we have negative 1 times negative 1 minus 4, that's negative 5 times 21. So that would be negative 105. Okay, now minus 3 plus 4, that's plus 1 plus 4. Okay, times 4 rather, so that's plus 4. 6 times 2, or 6 plus 2, 8. 8 times negative 2, that's plus, negative 16. Negative 16. Okay. All right, so by the time we simplify these together, we'll be having minus 117. Okay, so we're done with the second part. So let's move on to the third part now. So third part. So let's clear this area so we can have spaces to work with or work in. All right. Okay. All right. So we want to replace the x2 column now. So write the x1 column as it is, 1, 2, 3. But the x2 column, instead of writing minus 4, 1, and 2. So write it as 21, 3, and negative 2. Then write the last column as it is, minus 2, 2, and negative 1. Okay. So again, find the determinant here. So determinant here. So you can see plus, minus, plus. So take out 1 outside. So 1 in the bracket of. So strike this. So 3 times negative 1. So that's negative 3. 2 times negative 4. 2 times negative 4, or 2 times negative 2 rather, is negative 4. So 3 minus minus 4, that's 3 plus 4. So this, you have to be careful when computing this. It's quite tricky. Then the second one has a place value of negative 21. Okay, so be careful again. Open our parentheses, strike this. So 2 times negative 2, that's negative 2. Okay, and 3 times 2, that's negative 6. Okay, I think we are done. All right, okay. Then moving on to the last one, plus minus 2, so that's negative. Strike this. So 2 times negative 2, that's negative 4. 3 times 3, that's 9. So negative 9. All right. So, okay. So I think, okay. I think we're okay. Yeah. All right. So let's simplify this. So negative 3 plus 4. So that's 1. So this is 1. Everything here is 1. Minus 2 minus 6, that's minus 8. So 21 times 8, so that will be 168. So this will be plus 168, because this is negative, when you multiply them together, it turns positive. Okay, negative 4, negative 9, negative 4, negative 9, so that's negative 13 times negative 2, that will be positive 26. And by the time we add everything together, that would be 168 plus, that's 169. 169 plus 26, that's 196. So here we have 196. Okay. All right. So just to rephrase, so 1 plus 168, that's 169. So 9 plus 6, that's 15. Okay. So this should be 195, not 196. So 195. Sorry about that. Okay. So moving on to the third part now. For the third part, so you can say you have to be careful. So while doing your arithmetic. Okay, so moving on to the third part. So write the first column as it is, 1, 2, 3. Write the second column as it is, 4, 1, 2. Now for the third column, switch it to a different thing, to the last number. and then find the determinant. So finding the determinant here, again, for the first one, we have 1 in the bracket of, so strike this, strike that. So 1 times -2, that's -2. 2 times 3, that's 6. So -2, -6. Okay. Moving on. The next one, we have -4, isn't it? Or +4 rather, because negative, that's +4. Okay. So strike this, strike this. So 3 times -2, that's -4. 3 times 3, that's -9. Okay. Okay. Now moving on. So lastly, +21. Okay. 2 times 2, that's 4. 3 times 1, that's 3. So 4 minus 3. And then this is what we have. Okay. So simplifying this, -2, -6, that's -8. -2, -6 is -8. Okay. -8 times 1, so we have -8. -4, -9, that's -13 times 4, that's 52, +52. Okay. And 4 minus 3, 4 minus 3 is 1. 4 minus 3 is 1. So there should be a negative here. So this should be negative, not positive. Because -4 minus 9 is negative 13. So by the time you multiply them, so it should be negative instead, not positive. So, okay. So 4 minus 3, that's 1. And okay, so +21. All right. So let's do the this one. So -8, -52 plus +21. So our answer here is -39. Okay, so to find our x1, so x1 will simply be the determinant of x1, so the original determinant of the matrix. So that's -117 over 39, and then we'll be having, so okay, so this is -39, so be careful. All right, so 117 divided by 39, so that's 3. So x1 is equal to 3. x2 is equal to x2 over delta A. Again, that's 195 over 39 minus 39. And this is equal to, so 195 divided by 39. So that's 5, -5. And lastly, -39 divided by 39. So that's x3 is equal to 1. So you can see how we use Cramer's rule to find the solution to a system of linear equation. It's quite simple. Bulky, yes, but it's quite simple because you are doing the same process all over again. So we start with forming the matrices from the variables we are given, and then we find the determinants of the original matrix. We also replace the x column with the constant. We replace the y column with the constant, and if it's still available, you replace the z column also with the constant. So after doing that, then you just try to divide the determinant of x with the original determinant, and then you get your x value. Divide the determinant of y with the original determinant, you get the y value. Divide the determinant of z with the original determinant, you get the z value. All right, so in our next video, we're looking at how to use Gaussian elimination method to also solve a system of linear equation. So we look at the Gaussian elimination method. What do we need to do? Which one is simpler? Which one is easier? So whichever one you feel more comfortable with, so you're free to use them in as much as the question doesn't specify or the question specifies. Who knows? All right, so thank you for watching. Have a nice day and bye-bye.